Hi there, welcome back to Mac Tech. Today, I'm just going to go ahead and continue my skills project video series. And today, what I'm going to go over is trunking. Okay, so up to this point, all of our hosts are addressed with IPv4 and IPv6. Same with our network devices, and we've verified connectivity between directly connected hosts. Okay. Now today, what we're going to go over is VLANs and trunking, right? I think I already mentioned that. So basically, what this is going to allow us to do is use our routing that we've put here, right? Remember we put our sub interfaces. I'll just open this up here and show you what I'm talking about. And this is called router on a stick, which essentially allows us to route between VLANs on the same physical interface. Okay, so I'm going to do a show IP. Oops. And then if you see here where it says .19, 22, 40, these are all the same physical interface. But that dot denotes a different logical interface. So it's as if we had several different router interfaces here for routing to occur between these subnets. Now you might think, oh yeah, we should be able to definitely these computers here should be able to, like this guy right here should definitely be able to talk to this guy right here. Well, that's not the case because they're on different subnets. They're so if I go here, if I go check out the IPv4 address, it, it's a 0.13 on a 224 subnet mask, and the one over here is actually, if I pull it up, it's on a different network. Uh, and I think I went over that before. Kind of, I don't want to dive too deep into how addressing works right now, but essentially different networks, different logical networks. That's why if I go here and pull up this guy, find the IPv4 address, go back to this guy, and then try to ping him, it's not going to work, as you can see. The reason being is because there's no routing taking place. Now, whenever we want to communicate across different subnets, we need routing. And right now the routing's taking place right here. However, this link from our switch to our router has not been set up as a trunk. So it's not VLAN aware, right? And along with that too, if we go to our switch, we don't even have the VLANs built out yet. If you see, VLAN 19, 43 through 40, we don't have those listed. So we're gonna need to build those, right? And along with that too, the ports that connect to the host are called the access ports. We're actually gonna need to specify a VLAN on that port as well, because what happens is, the hosts don't really know anything about VLANs. They'll just send their data like normal, and then as the data goes to the switch, it'll be added. A VLAN tag will be added to that particular data as it's passed along. So if this guy here wants to talk to this guy here, the data is going to go here. It's going to go to the switch. It's going to go to the access port. It's going to pick up a VLAN tag. VLAN tag is going to specify where, like, which VLAN it's on. That'll be part of the packet that's sent. The packet's going to go through the trunk port, which is VLAN aware, realizing that it allows this VLAN through. It's going to reach our sub interface, which is acting as the default gateway for this network. It's going to then see where the destination IP is, and as you know, IP routing only occurs on a router. It wouldn't. It would have the switch needs to have the route in order for IP addressing to work. And then it's going to see, oh yeah, it's okay. Our destination over here. What's the default gateway for that destination? It's this other VLAN 19 sub interface. So it's going to come out. It's going to come down here. Going to come back through the switch, and then it'll eventually end up at our host. Okay. So now that I kind of explained why we need VLANs, I'm going to go ahead and configure this. And today I actually have a config file. It's going to help us move things along a little bit. Okay, so I'm just going to go over the commands basically, and then I'll paste them in. So first we're going to enter. So I'll just do that part now. We're already in there. All right, global config mode. We're going to go to configuration mode. And then, so remember I said we needed to make this interface a trunk, or sorry, this this cable, a trunk is maybe a link. Sorry, that's the right word. Link from G01 on the switch to G00 on the router. So these are the commands that we're going to implement in order to do so. So we're going to go into the interface. We're going to say, hey, you're going to be a trunk port. And then this is where we're going to specify which VLANs are able to go across. So one is, native default, which I'm not going to go over right now. 19 would be our help desk. 22 would be management for the switch. 40 is for sales, HR. You see you see what's going on here. So whenever the trunk port receives a tag from one of these subnets, it's going to say, okay. For instance, if HR sends some sort of data to the switch, it's going to say, oh yeah, good, I know about HR. That's VLAN 41, and it's going to pass it along. Okay, so I'm going to go ahead and paste all this in there. Okay, bada bing. Now we're going to verify. And in order to verify that the trunk link has been created, we're going to do show interface trunk. And as you can see, G01 has been set up. It's on. We got our encapsulation.1q, and that's the same. These are the same we call protocol that we have over here on the router to be able to have sub interfaces. And it's trunking, so we're good there. You see the allowed VLANs, all the ones that we specified. Good, we're good to go there. All right. And moving on. Now we're going to need to do is we're going to actually create the VLANs within the switch. As I showed you earlier, if I did a show VLAN brief, I'm not seeing any of my interfaces or my VLANs that I need. I only have 1, 22, and then these other default ones that are already there, but we didn't even add those. But I did add 22, but any of our host subnets, we don't have the VLAN specified. So what this command does is when I place this command in config mode, the VLAN's automatically created. But it's always very helpful to actually name it. If you don't give it a name, you can just get confused on what it's for, and it's just good documentation. So go ahead and copy this in there now. Okay, perfect. And then what we're going to do is just verify that those VLANs showed up. Okay, perfect. Yep, there they are. So we got 19, 22, then 40 through 43. As you can see, they're all named accordingly. So we got that. Now, as I mentioned before, we're going to need to specify our access ports on this switch, right? And basically, the two ports that you need to be aware of are the trunk port, which we put here, and access port, which we put here. Those are basically the two types of switching ports that we'd have on a switch, right? So yeah, the access is going to be connected to hosts, and typically trunks will be connected to other network devices. All right, so I'm going to go ahead and let me go over this real quick. So I'm going to specify the interface range when I add this. I can add all of these. So for instance, here sales, we have fast Ethernet 1 through 4. I can apply these commands simultaneously to all the ports without having to go into each one. It just saves a lot of time. And you'll see switch port mode access. We'll make it an access port as opposed to switch port mode trunk that we put in earlier on G01. And then we're going to specify the VLAN that we want the data coming in to be tagged as. So here, the data coming from this server going into the switch would be tagged as VLAN 40. Okay. And then as you can see, it'll just be the same for all the other interface ranges that correspond to the particular VLAN. I'm going to copy that. I'm going to go ahead and paste it in. Cool. And now let's do a show IP interface brief. Or shoot, no, sorry, I think this is the wrong one. Let's do a show interface status. Cool. All right. So now we can see, right, our ports 1 through 4, VLAN 40, which is what we want. And we should see every 4 should be one of our VLANs that we specified. And it is. And then if you look down here too, there's another way we could have tested the trunk port is we could see G01 is connected as a trunk port. So we're good there. and it looks like they're all connected. So they're all on and active. So that's perfect. Now, remember our test earlier, right? So this should work now. This should definitely work. So let's see what happens when we try to ping. Remember what I'm doing here is I'm trying to ping this guy over here on another VLAN. Perfect. Okay, I remember the first one usually times out the first time you try to ping it because it's running an ARP request. So it looks like, yeah, it went through this time. So excellent. So that's how we know that our data is being tagged with a VLAN here. It's being passed along the trunk port here. Then it's being routed to another subnet on the router, sent back to the switch, and then from there, the MAC address table is sending it to the proper destination. And same thing, I did the same thing down here. However, just as before, in order to save time, I went ahead and just did it. The only thing is, though, here, you probably notice that there's 4 cables here connecting these 2 switches. This is what I'm going to talk about in the next in the next video. It's called ether channel, and it does relate to trunking, but I'm going to dive more into that a little later. But that should be good for now. All of our hosts can talk up here, and just take my word for it. All of our hosts can communicate down here, at least on these particular routers. Now, if I try to ping from this guy to this guy, it's not going to work because this link isn't active. It's not carrying any VLANs. But we will address that problem in the next video. Appreciate you watching. Bye now.